1.1 example 4. Another way to transform or change a graph is by multiplying the output values by a factor. When you multiply by a factor greater than 1, like 2, it doubles your outputs. So it stretches it vertically. So you can see our original function and our 2 became a 4, right? So it stretched it vertically, vertical stretch. If you take your parent function and you take all the outputs and you multiply them by a factor between 0 and 1, such as 1/2, it shrinks the output. So it's taking our 4 and now cutting it in half to 2. So it shrinks it towards the x-axis. So I'll demonstrate this with a quick table. So let's have our input values, our x values. We'll choose -2, -1, 0, 1, and 2. And first we're going to graph the parent function, where y equals just the absolute value of x. And then we'll graph with a 2. We'll multiply it by a factor of 2. 2 times the absolute value of x. Okay, so for our parent function, the absolute value of -2 is 2, because it's 2 units away from 0 on a number line. -1 is a distance of 1 from 0 on a number line, so the absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So these are our inputs. These are our outputs. Remember real quick, inputs and outputs on a graph, those are our x and y's. So x, y, right? You always go along the x-axis first and then to the y. So our inputs are the x values and our outputs are the y values. And we also call these f of x. So when we do something to the whole function, we're doing something to the output. Okay, so now you can see our -2, 2, -2, 2, that's here. -1, 1, 0, 0, 1, 1. So we're seeing our parent function graphed. Okay, now we're gonna see how the 2 vertically stretches the graph. So when I plug a -2 in, I get a 2, and then I'm going to multiply that by 2, and I get 4. So it's vertically stretching all of my original outputs. The -1, absolute value is 1, multiply that by 2, I get 2. Absolute value of 0 is 0, 0 times 2 is still 0. Absolute value of 1 is 1, 1 times 2 is 2. 2 times 2 is 4. So now our input is -2 and our output becomes 4. When our input is -1, our output becomes 2. 0, 0 stays. 1 becomes 2, 2 becomes 4. So our graph has been vertically stretched away from the x-axis. So vertically, it's being stretched in an up and down direction. Okay, now that's if you multiply if a is greater than 1. So here it was a 2, a 3, or a 4, or a 5 would have just stretched it even more. Okay, down here, if a is greater than 0, but less than 1. So remember, it can't be negative because that would flip it upside down. But if it's between 0 and 1, it's going to be a fraction of the output, so it's going to widen our graph. Okay, so first let's plot our parent function. -2, -1, 0, 1, 2. So our parent function of a parabola is y equals x squared. So when I put a -2 in and square it, I get a +4. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So we can see in blue, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So that's our black parent function. And now we're going to put a 1/2 multiplied to the front. So when I put in a -2 order of operations, I have to square it first. I'd get 4. And then I'm taking half of 4, which is 2. So I'm shrinking my outputs. Plug in a -1. -1 squared is +1. Half of that is 1/2. Half of 0 is still 0. When I put a 1 in and squared, I get 1. Half of that is a half. 2 squared is 4. Half of that is 2. So -2, 2 is here. -1, 1, -1, 1/2, 0, 0. 1, 1/2, 2, 2. So we have shrunk all of our outputs vertically. So they're being shrunk towards the x-axis, which widens our parent function. Okay, next let's do a little review. And you can do this on your own and then pause the video and come back. Graph the function and its parent function, describe the transformation. Well, I can see here that 3 in front is going to vertically stretch. So I could graph every point, but I know my parent function. And then if it's stretched, my points are going to get stretched vertically. And 0, 0 remains. So that is a vertical stretch by a factor of 3. If I put a 3/2 in front, I have to question, is that greater than 1 or is it between 0 and 1? So 3/2 is equal to 1.5. So this is also a vertical stretch, similar to the number 1. Here I have 0.2. 0.2 is 2/10, which also can be reduced to 1/5. So if I take my original parent function, which is a v, I'm going to be taking 1/5 of all those outputs. So it's going to widen or shrink my graph vertically, shrinking it towards the x-axis. Vertical shrink by a factor of 1/5 or 0.2. Okay, example 5, lastly, we're going to just describe combinations of transformations. So we have translations, left and right, up and down. We have vertical stretches and shrinks, and we have a reflection that flips. Okay, so you can go into Desmos, and you could plot the parent function of this, which would be y equals the absolute value of x, seen in black here. And then you can graph this function and see that it has a combination of changes. So the negative in front has flipped it upside down. The +5 on the inside moves it to the left 5. So that's the one that is opposite. And the -3 on the end has moved it down 3. So we have a reflection. We have a horizontal translation or shift. Left 5. And -3 on the end, we'll shift it down 3. A vertical translation down 3. Okay, so you could make a t-table for these, but once you get the hang of it, these are the same for all functions. So remember, the negative in front is a reflection. On the inside of a function, that's that horizontal shift left and right. When we add 5, it goes left 5. So it's sort of the opposite of what you would think. Opposite of h, same as k. The k is on the outside when you add something to the outputs, right? Here we're adding to the inputs. So we're doing the opposite or subtracting from the inputs. When we do it to the outputs, it goes up and down what we would think. So you can refer back to example 1, I think. All right. So lastly, let's just try a couple more. So this is our parent function. The negative in front is going to flip it. The 1/4, let's see if I multiply by 1/4 in the front, that's between 0 and 1. So that's going to be a vertical shrink. In this case, that will make it less steep. And when I add a 5 on the end, it's going to go up 5. So again, it says use a graphing calculator to graph the parent function, then graph this function and describe the transformation. So I'm describing the transformation. Please go into Desmos or a graphing calculator and get a graphic to see for yourself. Okay, if you try this one, you're going to see a vertical stretch, which stretches your graph away from the x-axis, which makes it look narrower. The -5 on the inside is going to go right 5 because we're subtracting from the input. So we're doing the opposite. So you can imagine if I put a 0, 0, 5, it goes 0. Yeah, it's going to go right 5. And -1 is going to go down 1.